All right, let's talk about a concept that's so fundamental to our digital lives, it's pretty much invisible. I mean, it is the hidden engine behind almost everything we do online, from your social feed to your shopping cart. And it all kicked off with one brilliantly simple idea.
I mean, really think about it. How does your favorite app know your shopping history, your friend list, your saved posts, and then serve it all up to you instantly? This ability for a computer to just answer any question you throw at it, it feels like magic, right? Well, it wasn't always this easy, not even close. In fact, it used to be a programmer's absolute worst nightmare.
Just try to imagine having to rewrite an entire application from the ground up just because you wanted to ask a slightly different question. Yeah, that was the painful, frustrating reality for programmers back in the 1960s. Data wasn't flexible. It was just stuck. It was messy, rigid, and totally trapped inside the machine. So this is the story of one single elegant concept that brought order to all that chaos and really unlocked the potential of information for the entire world. Okay, so to really get why this was such a breakthrough, you got to understand the problem first. Let's step into what I'm calling the data prison.
So back in the day, early databases used this thing called a hierarchical model. The best way to picture it is like a super rigid family tree, or maybe one of those company org charts. In a system like this one, a project might be the child of a part. Every single piece of data was locked into this strict parent-child relationship. It might sound organized, but believe me, it was incredibly inflexible.
But what if you wanted to look at the data differently? Say you wanted to see which parts were part of a project, instead of the other way around. Well, too bad. You couldn't just ask. You literally had to build a whole new, separate, rigid structure just for that one specific question.
And this is the real kicker. A program built to navigate that first family tree was totally useless on the second one. Asking a new question meant your old code was basically garbage. The systems were brittle, they were crazy expensive to maintain, and honestly, just a massive headache for anybody trying to build something new. This whole mess, it actually has a name: data dependence. And what that means is the app itself, the code, was completely handcuffed to the physical structure of the data. You change the data structure even a little bit, boom, your program breaks. You want to write a new program? You had to know every single tiny detail of how the data was laid out. It was holding everything back.
But then, an IBM mathematician comes along with an idea so simple and yet so powerful that it was about to tear down the walls of that data prison for good.
So the hero of our story is a guy named Edgar F. Ted Codd, and back in June of 1970, he published this paper called A Relational Model of Data for Large Shared Data Banks. Now, it didn't exactly make a huge splash right away, but inside that paper was the seed of a total revolution.
And here it is. This is the big aha moment. On the left, you see that tangled, rigid tree structure we were just talking about. Codd's solution is on the right. He basically said, let's just throw all that complexity away. His idea was radical in its simplicity. What if we just organized all data into simple tables, rows and columns? He called them relations. And that's it. That was the idea.
Now, Codd was a mathematician, so of course he had a few simple, elegant rules. In these tables, each row represents a unique item, and you can shuffle the rows in any order without changing what the data means. The columns, on the other hand, they define the properties of those items, name, price, or color, and their order is important. It's this beautiful simplicity that made it so incredibly powerful and flexible.
And all of this was serving Codd's central mission. He called it data independence. He wrote, and this is so key, future users must be protected from having to know how the data is organized in the machine. In other words, a programmer should be able to just ask for information without having a clue how it's physically stored on some disk drive somewhere. He wanted to completely separate the question from the storage.
Okay, so Codd has this brilliant idea. But turning a genius academic paper into an industry that changes the world, that's a whole different ballgame.
Now, you'd think IBM would be all over this, right? It was their own researchers' idea. But nope, not at all. See, they were making millions from their existing hierarchical database, IMS. Codd's relational model wasn't an opportunity to them, it was a threat to a cash cow, and the company just pushed back.
But here's where it gets interesting. While IBM was dragging its feet, other people saw the genius in it. So in 1979, this tiny startup called Relational Software, you might know them better today as Oracle, they shipped the very first commercial relational database. And with that, the floodgates just burst open. Just 2 years later, Cod himself gets the Turing Award, which is basically the Nobel Prize for computer science. And by the 90s, his idea wasn't just a theory anymore. It was a $12 billion industry.
There is a really fascinating and kind of sad footnote to this whole story, though. The founders of companies like Oracle became billionaires multiple times over. But Ted Cod, the man whose brain came up with the entire concept, he never really saw that kind of money. His colleague Chris State said it plainly. The sad thing is that Ted never became rich out of his idea. Other people did, but not Ted.
But hey, money isn't the only measure of impact. And Cod's real legacy? Well, it's way bigger than any bank account.
Even his old employer, IBM, eventually saw the light, and I think their summary of his work really nails it. Before Cod, building a database was kind of a dark art, a messy craft. He came in and applied the rigor of mathematics and logic, and in doing so, he turned it into a true field of computer science.
And his colleague, Chris State, I think he said it best. See, the relational model isn't just some technology that gets old and replaced in a few years. It's a foundational concept. It's as fundamental as grammar is to language. It is, quite literally, the bedrock our entire digital world is built on.
So just let that sink in for a second. A simple, elegant idea from over 50 years ago is still the engine running pretty much everything today. And that leaves us with a really cool question to think about. What simple, elegant idea from right now, one that maybe we're all overlooking, what's going to be the invisible foundation of the world in the year 2075?